But there is a difference. Okay, there's a difference in how each one of them are going to react. We usually think of T cells because we hear T cells being referred to. Oh, Lord, just a swing. Because we think about the T cells because of AIDS, right? Okay, so okay? Now, this representation right down here where we've got these white vessels, and if y'all need to come closer, come on, okay? Where we've got these white vessels with these little green dots, this is representing lymphatic vessels and a lymph node. So, let's say, and so we would have lymph nodes. Do you guys remember areas that lymph nodes were located? Okay? So, in these areas where the lymph nodes are found, okay, those lymph nodes, among them, are going to have probably 1 million of these T cells sitting. Some of them have already mounted an attack and are a memory cell. Some of them haven't mounted attack and we need them. All right? So let's say that since we got the 4 to work with right here, okay, all 4 of these are going to have T cells. Is that correct? So let's say that that invader that we need to mount the attack, that little antigen piece, that hapten or that molecule has been brought to these 2 nodes, okay? In these 2 nodes, if we haven't mounted an attack before, T cells are going to be activated because they have been presented with that little piece of antigen. Is everybody following me? So in 2 of those nodes, T cells have been presented with that antigen. I didn't have to present it to these 2 nodes. So the T cells that got the presentation get activated. I don't need the T cells here and here to be activated, just the ones that I've presented it to. I then need them to do what they need to do and then clone. And if they can clone, they can move out of that lymph node, they can have the stuff that comes through that lymph node, they can go out and go, ha, I'm here, too bad, too sad, you're dead, to that invader. Yes, no, maybe.
Do they leave a clone behind?
The clone will be left behind and made into the memory cell, become the memory cell.
Okay. And are those multiple or?
For the memory cells,
The clones, they make a lot of them?
they'll make a lot of them so that they can go and be dispersed throughout the body to fight the invaders. Yes, no, maybe.
Yes, good visual.
Okay. Might come back to it. Okay. Just try to make sure it was in the video. Okay, so we have the cellular response and the humoral. Okay. So this function that those lymphocytes are going to do, all right, we're going to find that cells in the immune system are going to be able to pick up that little hapten or larger molecule that it's losing the fight against in that second line of defense, and they're going to be able to pick it up. and attach it to part of its cell membrane. And that's where they'll go to the nearest node and present it. So these are going to be termed antigen presenting cells, the APCs. Okay? So some of the cells, some of these white cells of the immune system. Now, when we begin to see that take place, do you guys remember the macrophages? Okay? Macrophages are one of them that's at that second line of defense. Is that correct? So a macrophage's job, whatever's trying to invade, go in and eat it, right? And that's how it'll get a piece and present it on its cell membrane. Okay? So when we can have the T cell get activated, before we can get any type of response in this third line, we have to activate that cell. We have to activate that T cell. So, this requires that antigen presenting cell, that macrophage that ingested some of that invader, put some of it out on its plasma membrane, and has now moved to the lymph node where the T cells will reside, the T cells and the B cells. Okay?
So an antigen presenting cell is always a macrophage?
Yes, for the most part, for our purposes.
Could there be a situation where macrophages and B cells and other types of cells can get rid of the problem or the antigen without the T cell activation?
It's possible because B cells will also generate a memory cell. However,
It's different.
your B cells have what's called T helper cells. So therefore, a T helper cell would have to come in and help the B cell. Okay? So we have T helper cells, T cytotoxic cells. T cells are kind of very interesting, to say the least. Okay? B cells, well, they're going to, if we think about the B cells, because they're going to be in the plasma, okay, B cells and that antibody and so forth, but don't worry, we're going to get to that, okay? So this lymphocyte, the T cell, okay, this one, the cellular immune response, because it's working with the T cell. Does that make sense? Okay? Because the T cell is found in the lymph node, and we're working against just that T cell. All right? So this is that cellular immune response. Now, we can activate the T cell, the antigen presenting cell, for the most part, would be that macrophage, okay? We can activate B cells. Now, the process overall can actually get very complicated. Now, I'm going to try to keep it at a level that doesn't get you too detailed. So what's going to happen to activate these lymph cells? It requires something called a major histocompatibility complex. When we look at this MHC, this major histocompatibility complex, or a human leukocyte antigen, HLA, our goal at this point is to make sure that those cells getting activated recognize the non-self cell. that we are not going to be attacking self cells, our cells of the body that we need. So, in this MHC, what's going to happen? The macrophage ingests, let's say, a bacteria, okay? It ingests that bacterium. In that macrophage, do you happen to remember what was inside the macrophage that could break up the bacteria? There are lysosomes, okay? So the lysosomes help that macrophage to digest that particular bacteria. Now, when it digests that bacteria, that macrophage takes a little piece of it, pushes it through its plasma membrane, and puts it on the plasma membrane. Okay? Got a little piece of it. Now, when we have this MHC and we've got the macrophage plus the little piece of that bacteria, what we're going to see now is we've got this complex, all right, that a T cell can recognize. And it's recognizing that this complex that's been created between that macrophage and the bacteria is non-self. Is that correct? Because it has something foreign on it. Does that make sense? So, we can now see that an MHC could recognize that particular pathogen, okay, recognize it as non-self, that T cell, and I'm right here with this MHC, okay, we can now see that the T cell says, hey, whoa, wait a minute, you're not part of this body right here. I gotta make sure you don't invade anymore. And the T cell becomes activated. And when it reacts, right at that point, when it reacts with that antigen presenting cell, we now have a cell immune response.
Would the T cell attack the macrophage?
It will attack the piece on the macrophage, yes. Now, the macrophage is not going to have a long lifespan anyway, so it may die after it mounts that response, or I should say it gets that response from the T cell.
Your last sentence, you said the T cell becomes activated and it reacts with the antigen presenting cell.
And it's going to recognize that it's non-self, that it's a foreign particle.
Okay.
If it begins to recognize that it's a foreign particle, and because we have now activated that T cell, we now need that T cell to begin the fight. And the T cell, note what it can do. What does synthesize mean? Create. Okay? So it can make and then secrete. What's a polypeptide? Poly means many. Peptide means what? What we have is the bond between the amino acid. So it can now secrete that amino acid chain, and these are termed cytokines. So, at this point, a macrophage, and we used a bacteria, ingested the bacteria, put a piece of it on its plasma membrane. It's now an MHC. The T cell recognizes that MHC as being foreign. We activated the T cell. the T cell can now make and secrete what's termed the cytokine.
And the cytokine is what fights the antigen.
The cytokine, their job, enhance that immune response to the antigen. So their job, enhance that immune response to the antigen.
Are the cytokines like the clones?
The cytokines are what the T cell that's going to begin to clone itself makes. So we got that T cell activated and it started releasing these. So when that T cell begins to clone itself, guess what it's going to make and secrete? The same cytokines. And a good example of a cytokine we had in a previous slide, the interleukins. Do you remember that term? The interleukins? We have interleukin 1, interleukin 2.
Has it been 15 minutes yet? It's less.